Hello! In this video, we will learn how to compute the standard error of the mean in RStudio. Inside of RStudio, we'll begin with a very large screen on the left for the console and also a clear screen on the right for the environment. We'll also begin just by reminding ourselves a little bit about what the standard error is. So we'll put in a hashtag and then also standard error. This is simply leaving a note to ourselves. And what we can say is that conceptually the standard error is the standard deviation for the distribution of means. But in this video we want the computational version of the standard error. So we can say that the standard error is equal to the standard deviation, which I'll abbreviate by SD, divided by the square root of the number of observations that we have in our data set. Okay, so here we have standard error is equal to the standard deviation divided by the square root of n, where n is the number of observations in that data set. So let's begin by creating a simple variable for which we would like to compute the standard error. We'll call that variable v1, and as we've done in other videos, we will insert into variable v1 a list that we'll begin by creating with the C command and the left parenthesis, a list of maybe 10 numbers that will go from 0 to 9. I'll just enter them and separate each of them successively by a comma. Okay, and so now I'll hit enter, and I have a list over on the right-hand side for variable v1. It's our data set. It contains these numbers. Okay. So the first step that we would want to do, and we've done this in other videos, is according to our formula, which is highlighted here, we'll want to take the standard deviation for this variable, which is v1, and we do that by keying in SD, open a left paren, we insert the variable name, and we wind up with a 3.02 and some change as the standard deviation for variable 1. Okay, so we're half the way there. We've completed the numerator of the standard errors computation. Let's move on to the denominator, and to do that, we'll have to learn just a couple of commands. Some of you might recall in a prior video, we had learned about the square root command, which is SQRT. We open a left paren, and then we stick in a number for which we would like the square root. We'll start out with a couple of obvious examples here. You might recall that 64 is a perfect square. It is the square of 8, and we can click on, instead of 64, 100 as the number for which we would like a square root, and the square root of 100 is 10. So I hope to have convinced you that the SQRT command does in fact take a square root of whatever number you insert. Here, we're going to want to take the square root of the number of observations that we have, and that is expressed by the letter n by scientific convention. So what we do need to know is how long our particular variable is. And when we say how long is the variable, or we ask about how long the variable is, we're asking about how many elements are in the variable. There is a very simple command for determining the length of a variable as expressed by the number of elements, and that command is very intuitively called the length command. So I can put in the word length, and then I can enter the variable for which I would like the length, or the vector size to be slightly more technical. So the length of v1 will turn out to be 10 elements. So I would like to take the square root of 10 because I happen to have 10 elements in here. My n is equal to 10 in this case. So that's going to be the denominator of my term, or my expression for the standard error. So from the beginning, we can say that the standard error of v1 will be equal to the standard deviation. We'll open a left parenthesis, v1. Okay, that's going to be the numerator. We'll put in divided by sign, and now we'll take the square root of something, and I could put in the literal number 10. In fact, I'll do that here, and you'll see that I wind up with a standard error equaling 0.957 and some change. I can hit the up arrow key to bring back the command I just had, and I can now engage in what we might call an embedded function, or a composite function, or a nested function. That is, inside of the square root command, I can insert yet another command. I have a command inside of a command, and here I can put in the length command, which again would be the length of v1, as we had done a moment ago. We know that's 10, but here we're using an embedded function to complete the denominator of our standard error computation. So I'm going to take the standard deviation for v1 and divide that by the square root of the number of observations, which I can retrieve by taking the length of v1. And when I hit enter here, again, I come to the same answer I did a moment ago, the standard error equaling 0.957 and some change. Thanks for listening.